All right, hi everybody. This is the lecture Intro to Science. So what is science, right? Um, Science is come a long way. So a couple hundred years ago, maybe around the 18th century or so, there's a group of people who kind of split the world, if you will, into two categories. They split them into art and science. And this split, this subjective versus objective split, was previously not done anywhere. I mean, it was a brand new thing. Up until that point, up until about the 1700s, there was a branch of science, and it was kind of a holistic sort of, it took everything into account branch of science. It was practiced by Catholic monks. It was practiced by spiritual people. It was practiced by a whole bunch of people. And for the most part, it's called alchemy. And alchemy was this idea that, there was a chemical basis of life that could be, the principles from which could be extracted through experimentation. The problem with alchemy was that the people who were practicing it also had a firm fundamental belief that the constitution of the experimenter's soul, or their spirituality, if you will, directly influenced the outcome of their chemical experimentation. So they were actually, they were saying it's all one. So you have the person doing the experiment is also, and their constitution is affecting the outcome of the experiment. Now that actually, what's interesting about that is that, like I said, there was a split. So the spiritual side of alchemy, like the personal, the intrapersonal transformative side of alchemy, split off. The part that was like, hey, you got to become a better person to do better experiments, that split off. And what remained was the objective side of it. Was like, okay, if I take 10 mils of this and 5 mils of that, mix them together, poof, I can make something explode. And so that side went on to go become chemistry and the natural sciences and stuff like that. And so what is science? Nowadays, science we consider to be an objective understanding of the world, something that we can verify transpersonally. So between people, we can say, I can do something like combine 5 mils of this and 10 mils of that, and I can make something happen, and then I can tell you how I did that, and then you could take and do the exact same thing as me and get the same exact results. So it would be, it would be independent of our own personal constitutions, right? And so that's what science has become. But there's there's a process to science, right? There's a process, and to me, the process that we do is a refinement of the way that we already investigate reality. And so what we do in science is we see something. Here, I'm going to start my PowerPoint. We see something. What is science, right? And so it's a systematic study of structure and function in the natural world through experimentation, right? That's the textbook definition of it, right? But it's through observation and experiment. Okay, so we'll start with the first part of that, right? Let's tease out what this actually means. The systematic study. So systematic means there's a method, right, of the study that's studying structure and behavior. So how are things arranged and how do they behave in the natural world through looking at it, right? Observing it, paying attention to it, and also manipulating it, experimenting with it. So let's go to the first part, right? What is an observation? So this is where you observe something, you use your eyes or some sort of sense. It doesn't have to be visual, right? Where you observe something to get information from it, right? That's an observation. And so what if you see something out there that you make an observation that doesn't make sense to you, right? It could be that, um, you're going about your daily routine, and then something pops up that's not part of your normal routine that you've seen, right? So you're like, what is that? Okay, so what do we call that? What do we call something that we see, we observe, but we can't quite explain? We call it a phenomenon, right? We call it a phenomenon. So this is a situation that's observed whose cause or explanations in question. So this could be like, it could be personal. It could be something like a phenomenon. It could be that you walk into school and nobody wants to talk to you. And you're like, well, usually I'm a social butterfly and everybody wants to talk to me. That's a phenomenon. It's a situation, you're observing it, and the explanation is in question. You're like, why is this happening? But there's a million types of phenomena, right? There's like paranormal phenomena. There's like You know, there's like UFOs phenomenon. There's all kinds of phenomena. So we gotta separate, right, the wheat from the chaff. We have to say, okay, what sort of stuff is of interest to objectable, repeatable science, and what sort of stuff is not. So like I said, what sort of phenomena are of interest to science? Repeatable phenomena, something that you can make happen over and over again. So in the case of you went to school and nobody was talking to you, right? You can still repeat that because you know still nobody's talking to you. So you're still wandering around trying to get an explanation for what's happening. Is it controllable? Can you manipulate it, right? Can you ask questions about it? Can you do experimentation on it, right? And so what we do is we say there's two phenomena, right? Or there's two categories for this. One of the phenomena, like this is the separation of wheat from chaff. One category is something that's of interest to science, it's repeatable and controllable. And the other one is not of interest to science because we can't replicate it or control it. So that would be something like I was driving my car and I saw a flying saucer zoom down the street. Great. Can you make it happen again? Then it's not of interest to science. Does it happen every night? No. Then it's not of interest. It's not predictable. It's not repeatable. It's not of interest to science because we can't, you know, it's not going to happen again. It was a phenomenon. It begs explanation, but we don't know what it was. So anyways, I'm going to give you two examples here, right? There's two examples of phenomena. And I want you to think about which one could be of interest to science, right? So we've got the spirit orbs. Let's check out this video. And don't judge me, right? It didn't take me long to find some ridiculous stuff on YouTube. So here's our spirit orbs, right? And look at them. Oh man, they're just floating around. And look, angel spirit orbs are caught on camera, right? So they're floating around. Whoo, look at that one. But they get better. So the person finally figures out how to use their cell phone camera. Oh, there's one. Oh man, look at them. They're everywhere. Look at all these angel spirit orbs, right? Okay, that's pretty interesting. Now, what I want you to do is I want you to look around the room. Right? We're seeing all these orbs, right? These are unexplained phenomena as they are, right? Look, they're all over. They're flying around. I mean, it's insane. Look at that. Oh, dude. Look at that blue angel one. Okay, so anyways, look around the room. What do you see, right? Is there anything you see that could make this of interest to science, right? Okay, so we'll come back to that one. Let's go back to this one. Okay, so we said, oh, I went too far, sorry. Okay, and then we have the UFO. Okay, so here's this one. And people are on an airplane. It's narrated, but we gotta skip the ad. Apologize for that. I don't have YouTube Red or whatever. There it is. Carrie, what is that? I have no idea. Holy crap. They can see it out the window of their airplane. Nobody knows what it is. Dun, 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 dun. It makes seemingly impossible maneuvers, right? Strange. Okay. All right. So I'm going to shut those windows down and pretend like and erase them from my history. So anyways, so you have those two. So which one is of interest to science? Which one's repeatable? You can pause this video, think about it for a second, and I'll just tell you the answer. The spirit orb one is repeatable because that's a phenomena, right? And I saw something, I was able to see something in that video that gave me a clue as to what might be causing these spirit orbs they're actually not spirit orbs. In fact, what I think they are is I think they are dust particles from the fire that is burning behind the person in the room that's kicking up all these little ash particles that are bouncing off the light of his camera, and then they're not in focus, so they show up as orbs. That's what I believe. And so what I could do is I could set up an experiment where I film with the fire going and film without the fire going, and hey, we might notice something. Okay, anyways, carrying on. So what do you do with a phenomena? My son has this book called What Do You Do With an Idea, right? It's a kid's book. So what do you do with a phenomena? Well, you've identified it, and it's of interest to science, so now what do you do with it? Well, you ask the question. So again, this is the scientific method broken down, right? So you ask the question, why did that happen? How did that happen? What made that happen, right? And then what? We got to form a hypothesis, okay? So a hypothesis is a testable explanation for an observed phenomena and is developed after you ask the question about the phenomena, right? So you could say, if we're using the spirit orbs, right, we could say, oh, I saw this happen. I was filming, all these cool orbs showed up, right? Posted the video. Someone sees it too. They're like, that's crazy. And then they ask the question. They say, what is making that happen? Form a hypothesis. I think that it's the fire behind the person that is reflecting off the ash, and then it's not in focus, and it's causing the spirit orbs to appear. Okay, so the hypothesis is the explanation for it answers the question that was posited about the phenomenon. Again, and what do we mean by testable? Well, you got to be able to design some sort of experiment to test the accuracy of your hypothesis. And a hypothesis can be like, I mean, hypothesis is it's a word that is used ubiquitously all over science, right? We use hypothesis. Oh, I hypothesized that this would happen. The thing about a hypothesis is that it can be a model, it can be a math model, right? So, for instance, this coronavirus thing, right? All these science universities are all doing models of the virus and how it's spreading and blah, 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 right? Those are all hypotheses. They're a model. It's a math model, right? And so how do we test our math model? Well, we use it to make predictions and then see how accurate those predictions are. And if they're accurate, if we're able to predict well, then we say our hypothesis or our model is correct, right? And so that's just one type of hypothesis. And then there's many others, and we'll talk about those as we go on, right? So we got to design an experiment to test the accuracy. So the question is, so what types of experiments are there that we can do for science, right? The first type that you're most familiar with is going to be an experimental investigation, right? So it's going to be like you take a group of people, you split them into, you give half of them a placebo, half of them you test, right? Or it doesn't have to be people, it could be plants, right? You could take identical copies of like tomato seeds, right? And you could plant them all, grow them, and then like split them into two groups, and half of them you give blue light and half of them you give regular light, and you just say I think plants do better in white light than blue light, right? So that would be another type of investigation. So usually what we do in an experimental investigation is we control every variable except for one to see what that variable's effect is between the two groups, right? A good example is blood pressure medication, right? Like I said, you split people into two groups, right? Completely randomly. Give one group a placebo, one group the blood pressure medication, measure their overall change in blood pressure over a given interval of time, compare the results, and see if one of them was actually significantly lower than the other. And what's crazy is sometimes the placebo is actually lower than the actual medication. That means people that think that they're getting a medication change their body chemistry so that it actually works. It's crazy. So what do you call that, right? Is that science? Who knows? Okay, another type of investigation is purely descriptive, right? So this is where I'm just curious about like something that I can measure, like I could say, oh, what's the weather going to be like tomorrow, right? So I can go and do some research and find out what the weather is going to be like and the temperature that the weather is going to be, right? And the type of environment, whether it's sunny, cloudy, rainy, right? Those are descriptive questions, right? Is there going to be clouds tomorrow? Is there going to be sun tomorrow? Is there going to be raining? What's the average rainfall in Phoenix for a year, right? Or how much does it rain during the month of July? How much snow on average is accumulated in the mountains of Colorado, right? These are all things that I can answer with just a measurement, right? I can take a measurement and that answers my question. How fast do cars drive on average on the freeway, right? I don't have to manipulate anything. I just have to go out and measure it. That's a descriptive investigation. And then comparative investigations are where I want to compare a variable between more than one group. So I use the example of like, how does altitude affect the temperature at which water boils? So there is no control group, right? I'm not splitting them into two group and just, boiling one at sea level and the other ones at different altitudes, right? I'm comparing between altitudes. So I'm saying, how does altitude affect the temperature at which water boils? So I have 100 feet altitude, 1,000 feet, 10,000 feet, right? I compare, set it up where I start boiling water, make sure the water is the same temperature at all elevations, right? And then I just see time how long it takes for it to actually boil, right? But I'm not actually I don't have a control group. I don't have somebody that I'm giving a placebo to, or that I'm not actually involving in the actual experiment itself. And so that's a comparative investigation. Another example for you stoners out there could be, let's say I have a whole bunch of cloned plants, medical marijuana plants. I have a bunch of clones of the same strain, and I put them each in a different pot, right? So they're all the same genetically, right? I put them all in a different pot, and I ask the question, okay, how does the soil affect the potency of the THC that's produced? And so I have one that's in Miracle Grow, I have one in regular garden soil, I have one that's in mulch, I have one that's in this. So there's no like control group, right? They're all in different soil conditions, and all I'm testing for is how those soil conditions affect the THC produced. And it's a genetically identical plant, so that means that it has to be the soil condition that's causing the change, right? And we'll talk about that as we go on too. Okay, so that's a little break right there. If you want to just pause, go get a drink of water, and we'll start on lesson 2, the application of science. All right, we're back. Let's do this. So this question is, so how do we apply this? So we're going to give we're going to give you guys some examples of each type of investigation and kind of go into more details about what's involved. Okay, so what kind of phenomena would warrant a descriptive investigation? Well, when you want to make some sort of qualitative or quantitative observations about one type of thing in one general area. I know that's a super vague definition. So we said, like, what's the average rainfall in Phoenix, right? So that's a quantitative observation about one type of thing, the rainfall in one general area, Phoenix, right? What's the tallest mountain in the world? That's a quantitative observation, right? Let's see. What is the average speeds of cars? We did that one, right? So those are all descriptive questions, right? So what kind of things you need to do that sort of investigation? Well, you need the phenomena, right? So you're like, oh, I noticed it's raining a lot in the month of July in Phoenix. I wonder how much it rains on average in Phoenix. So you got the phenomena, right? How much does it rain in Phoenix, right? The measure variable, how much does it rain, right? You might have some control. So you might say, like, okay, maybe I have to make sure that I'm taking my daily rainfall measurements every day at noon, right? And maybe it rains more like in the morning or something, or in the afternoon. So I want to make sure I'm taking the measurements at the same exact time, right? Same day of the week, that sort of stuff. Okay. Also, I'm going to probably present my data with graphs, right? Like, so I'll show like a graph of Phoenix's rainfall in July versus August or something, right? I might have to analyze some data. I might have to like take an average, right? I might take a bunch of measurements and take an average of it, and then I'll have some conclusion. I'll be like, I conclude that it rains an average of 1.75 centimeters every July in Phoenix for the last 20 years. Or, you know, I want to measure the size of the horns of beetles, right, and compare the average size of those. So that would be a descriptive question. Okay. All right. All right, so let's take a look at a comparative investigation. So what type of phenomena would warrant a comparative investigation would be, sorry, there we go. When you want to compare one variable between two or more groups, so this could be like different soil types, right, or something like that. So what type of ant would win in a fight? So maybe you've seen some black ants and some red ants thrown down on the pavement, but maybe one was outnumbered by the other ones. And so you're really curious, like, if they weren't outnumbered and all things equal, which one would be the better fighter? Which soil type would yield the highest amount of THC production in medical marijuana strains? What type of chest exercise, which type of chest exercise would give you the largest strength gains in the shortest amount of time? So these are all comparative. There's no way to have a control group or a placebo. There's no way that somebody can just fake doing a chest exercise, right? And, you know, that's your control group. So that's a comparative investigation, one where there isn't a control group, but you are comparing a variable across groups. Okay. So what do you need to do a comparative investigation? You need that phenomena, you need your question, you need to make a hypothesis. I hypothesize that flat dumbbell press or incline dumbbell press will yield the highest results for a chest exercise, right? Because of this X, Y, and Z, right? You have your procedure. You're going to need a methodology for how you're having these people conduct these chest exercises, right? You're going to need to identify your variables, right? The different exercises, right? How you're measuring the increases in strength gains in muscle mass, things like that, right? You're also going to need, how are you going to present this data once you figure it out? And then also, like, you're going to have a conclusion. Black and red ants is a great example of a comparative investigation. right? And the example I told you where you see a black ant getting its butt kicked by red ants and you're like, you know what, I want, even though the black ant was bigger and the red ants were smaller, pretend this is true, right? You might say, I wondered if those black ants would actually beat the red ants if there was more of them, right? Hint, hint, stomp, stomp, wink, wink, right? That's a test question. Okay. What type of phenomena would warrant an experimental investigation, right? Okay, well, that's where you want to measure one variable, right? So that could be like blood pressure medication on a group of similar things, like people who are over the age of 50 that are diabetic, right? So you want to test that one variable, the blood pressure medication, right? Or the vaccine for coronavirus on a group of individuals, right? That would be an experimental investigation, right? So what do you need for that? Well, you're going to need your phenomena, right? Well, I see there's a lot of people that are dying from coronavirus, so I would like to make a vaccine for it. Research question: what sort of vaccine would work the best for have the least amount of side effects in my test population? Hypothesis could be like, I believe that an attenuated virus that's a live attenuated virus would cause the best antibody response in my people. And then your procedure. So you're going to take 200 people, split them into two groups. One of them you're going to give a shot of sugar. The other one you're going to give them an injection of your experimental coronavirus vaccine, right? And then your variables are things like the age groups of your people, how much vaccine you're giving them versus how much placebo, what measured output of the experiment is, right? That sort of stuff. So let's break down variables real quick. There's several types of variables. There's independent variables, and these are variables that you can actually change, right? That might have an effect on the output of an experiment. So the measured output of the experiment is the dependent variable. That is the one that you cannot manipulate, right? So like a good example of that would be like, if I run a mile, what is my heart rate? Or if I run an 8-minute mile, right? What is my heart rate? You cannot directly affect your heart rate, right? You can't just be like, oh, I'm gonna make it fast, right? If you run an 8-minute mile, your heart rate is gonna be determined by the 8-minute mile, right? That's your independent variable, and the distance, the mile, right? So independent variables are the ones you can manipulate that have an effect on the dependent variable, on the measured output of the experiment, right? So in that case, what I just gave you, right, independent variables would be things like distance, right? Things like time, like how fast I'm running that mile in. Things like hydration, things like time of day, things like temperature, things like sunlight, cloud cover. All of these things are things that I can manipulate in some way, shape, or form, right? Like maybe I can't change the cloud cover, but I can wait for a cloudy day, right? So those are all independent variables. The dependent variable, though, that's what you're measuring. That's the effect, right? So with the THC plants, right? The THC content of the different soil, the THC content produced in the plants grown in the different soil varieties is the dependent variable. You cannot look at that plant and say, I want you to make more THC, right? You have to change something. You have to manipulate an independent variable like soil condition in order to change or affect a change in the dependent variable, right? The measured output of the experiment. And then controls are everything that is like an independent variable that could affect the output that you want to keep the same, right? So an example of a control would be something like temperature. Like let's say I'm doing the run experiment, right? What's my heart rate after I run an 8-minute mile, right? Controls would be things like, are you doing it at the same time of day? Are you going the same distance? Are you running the same pace? Are you all wearing the same type of shoes? Right? These are controls, things that might have an effect on your heart rate at the end of it, right? That you want to keep the same across all experimental groups, okay? And then you have a control group. So this would be in the case of the experimental investigation. This is the placebo group, right? So this is the group that gets everything except for the actual medication. Okay? And then, of course, you'll have your data, your graphs, your analysis, and then you'll have a conclusion. So what I've done next is I've put up this is a slide that shows an actual clinical trial of a medication, okay? It was for oral prednisolone. I can't even say that word. Anyways, so here's what they did, right? So they found 990 people, and they said, okay, we need to split these people into two groups and give half of them medication and half of them. Oh, it was for this. It was the fluconazole or whatever, you know. Anyway, okay. So anyways, they had 990 people, right? And then they filtered them down, and so they're like, okay, maybe 109 of them, you know, they had COPD, so it wasn't going to work out, right? This is for like a medication for breathing, right? For like allergies or something, right? Some of them had a heart attack. Some of them like got ran over by a car. Some of them got struck by lightning. Some of them didn't even comply to the study, right? Some of them didn't even come back. And then there was just other problems too, right? And so of the patients that actually made it into the actual trial, into the experiment, is this right here. It's the, here, let me do my annotation on this one. Where is my annotate? Give me something to draw with. Okay, how about a pencil? Or pen tool. Okay, so these guys are the ones that actually made it into the study itself. And so what they did was they said, okay, of these people, right, that we have, right, let's split them in half. And half of them are going to go get this placebo, okay? Half of them are actually going to get the medication itself, okay? So of the people that are getting the actual medication, right, some of them are going to get it orally, and some of them, right, are going to get, I don't know, some other form of it. I guess maybe they didn't take it, right? And then of the people that get placebo, some of them get the oral placebo, and then some of them don't. Okay, and then some of them had bad reactions to either the placebo or the medication, and they did not come back. So a couple people left the study. Start of the double-blind phase. So this is where the administrators that actually give the treatment have no idea whether they have the placebo or whether they have the treatment. That way they can't subjectively influence the patients to have a reaction to either the placebo or the treatment, right? And so 372 of them, you know what, probably some of these guys were having, this was just a preliminary study up here. And then here's the actual placebo. 370 got the placebo. 370 actually got the medication. Some of them didn't make it. So like almost half of them didn't even finish the study. For the placebo, more than half of them didn't finish the study. And it was for all of these reasons. So you can imagine, so like if you ever wonder like, oh, why do like the pharmaceutical companies charge so much money for their medications? Well, it's because of these doinks, right? That like can't finish their studies, and they had to pay them money to like not finish their study, right? And so if you look down here, these are people that were taking the medications or the placebo. So 200 or almost 300 finished the first year, right? So 80% of the people that started the double-blind phase finished the first year. Great. Only 74% of the placebo finished the first year. Oh, that's a problem, right? Wait, that's almost 6% less than the other ones. Why? Well, because they had the placebo. The stuff wasn't working. So they're like, I don't want to keep doing this study, right? And then another year goes by, some more people drop out, right? They're like, oh, I don't know. I still can't breathe that well, so I'll just stop taking this, right? And then only about half of them finish the study for both groups. More than half for the actual treatment, and then less than half for the placebo group. Right. So that tells you why these things are such a pain in the butt to do. And that was an example of a medication. It would be literally almost the same thing if it was a vaccine study. It would be almost a vaccine study. So anyways, let's go and let's just review real quick. Let's go on to the next slide. Okay, so we know that when you make an observation of a repeatable controllable phenomenon, that's a scientific question, or that's a scientific phenomena of interest of science, right? It's repeatable and it's controllable. Okay, it leads to questions. The questions that you have beg for testable explanations, and explanations are hypotheses, right? And like I said earlier, this is something that we do naturally, but we do it very poorly subjectively, right? So we tend to come up with hypotheses, we tend to not test them very well, and we tend to come up with erroneous conclusions, right? So like, for instance, my kid gets home late after curfew. He's 5 years old, so his curfew is like 7 o'clock at night, and he doesn't actually go anywhere. But okay, my kid comes home after curfew, right? And he's covered in mud, and he's dripping wet. Yeah, that's a phenomenon of interest of science, right? It begs the question, where have you been? Why are you late? And why are you wet and covered in mud? Okay. I'm going to hypothesize, okay, this kid was probably doing something stupid like swimming across a river and rolling around in the mud, right? I need to test that out, okay, using some sort of scientific investigation to test it. I can do that by just questioning, right? That's a descriptive question. Hey, where were you? What were you doing? Why was this? Right? Or I can actually go out and sample the mud from his body. I can go sample the water, see where it came from, that kind of stuff, right? Um, and like I said, those experiments can be descriptive, comparative, or experimental. And then where was I with my whole kid thing, right? So most of the time, like I was saying, we do these steps, right? But we do them poorly. And so like maybe I would just look at him and be like, "You're freaking late. Go to your room." And oh, I can't believe he was out, mudding around in his truck and didn't come home on time. And oh, I'm gonna punish him and blah blah blah, right? So but I didn't actually do a thorough hypothesis. I didn't do a thorough investigation, and so I come up with an erroneous conclusion. He was off dicking around and got muddy and came home late, and he's in big trouble. But it could be that maybe a friend of his rolled their car in the river, and he had to rescue them, and it took him a while, and he got home, right? And so I've made an erroneous conclusion from my crappy science in my head, right? I didn't do a good job of doing it. But we all do these sorts of things in our head. We just do them poorly. Science has said, okay, let's see if we can do this objectively where somebody else can do the same exact experiments as me or the same comparative investigation and come up with the same results. And then that supports the hypothesis. Okay. The best way to tell whether something's a comparative or an experimental investigation is whether or not there's a control group, right? Whether or not there's a placebo group. Okay. If it's one group compared to another group, like black ants versus red ants, that's completely comparative, right? If it's something like this group's getting everything the other group gets except for one thing, that's an experimental investigation. Okay, and so that was it for the investigation or the intro into science. I hope you guys enjoyed it. I'll catch you later. Bye.